We're going to start drawing angles on the Cartesian plane, and in this lesson, we'll be exploring the trigonometric ratios for angles greater than 90 degrees. First, we need to learn some very important terms. So we have our initial arm, and that's the arm where your angle begins, and then the terminal arm is where your angle ends. The angle measurement is between your initial arm and your terminal arm. And an angle that's in standard form, well, that's when your vertex is at 0, 0, the corner of your angle is at 0, 0, and the initial arm of the angle is on the positive side of the x-axis. So just like you see here, this is an angle that's in standard form. A principal angle is always in standard form or standard position, just like you see here. It's the angle in between your initial arm and your terminal arm. And again, it's always in this standard position. The related acute angle that you see here in green, it's always the angle that's in between your terminal arm and the x-axis. So wherever your angle is, or wherever your terminal arm is, it could be in this quadrant or one of these quadrants down here, it's always going to be the angle in between your terminal arm and the closest x-axis. And we often use this b, it's beta, to represent the related acute angle. And one thing to note, the related acute angle is always going to be a positive angle, and it's always between 0 or 90. So our terminal arm is right here, and our related acute angle is this angle right here. It's not the angle to the positive side of the x-axis, it's always the angle from your terminal arm to the closest x-axis, which is always why it's in between 0 and 90 degrees. And we can have positive angles or negative angles. So angles always start right here in the blue, where our positive side of the x-axis is. This is always our initial arm. And if we're going counterclockwise from that initial arm, this is a positive angle. But if we're going clockwise from the initial arm, so we're going down, this would be an angle that's negative. So try to become very familiar with these terms and understand what they mean. It's really important that you understand what the related acute angle is and what it is compared to the principal angle. And you will need to understand all of these terms moving forward in this course, but not only in this course, also in advanced functions. So let's work on some examples. Here's a Cartesian plane, and this quadrant in the top would be known as quadrant 1, or quadrant on the left is quadrant 2, on the bottom left it's quadrant 3, and the bottom right is quadrant 4. And we're being asked to draw 220 degrees. Well, right here at the top of this y-axis, this is 90 degrees. This is 180 degrees, and down here this is 270 degrees. So 220 degrees, that's going to be somewhere over here. So this is 220 degrees, and we often use theta to represent what the angle is. And we're also being asked to find the related acute angle. So if this is our terminal arm, the closest part of the x-axis is right over here, the negative side of the x-axis. So we're looking for this angle. And we can find that by just doing the measurement of this angle, 220, and subtracting 180. So when we do that, we're just going to get that beta, our related acute angle, is equal to 40 degrees. So this measurement is 40 degrees. So let me just explain again what happened here. So our angle theta, what we had here, our principal angle, was 220 degrees. And this is where the terminal arm is. And our related acute angle is just the angle from this terminal arm to our closest part of the x-axis, which is right here. At this x-axis, this is where 180 degrees is. From 0 to the other side of the x-axis, that's 180 degrees. So to find the measurement of just this beta angle right here, our related acute angle, we had to do 220 subtract 180. And then we got 40 degrees, so that was the measurement of our related acute angle. So let's actually try another one, and let's just label our quadrants real quick. We got 1, 2, 3, and 4. And we're being asked to draw this angle right here, negative 110. So if we label this, We start off with 0 here, but going down, we're going clockwise. This is actually negative 90 degrees down here. This is negative 180 degrees. And this right here is negative 270 degrees and will end at negative 360 degrees. So negative 110 degrees is just in between negative 90 and negative 180 degrees. That's going to be down here somewhere. That's our angle theta, which is negative 110 degrees. So that means we're looking for the angle between that terminal arm and this x-axis. Right here, this is our beta angle. So to find the related acute angle, we're just finding the difference between this negative 180 and this negative 110 degrees. So beta is just equal to negative 180 degrees minus negative 110 degrees. And if you actually calculate that, you'll get that it's equal to negative 70 degrees. But what do we know about our beta angles, our related acute angles? They're always just a positive angle in between 0 and 90 degrees. So we're just looking for the angle measurement between our x-axis and this terminal arm. And that's actually just 70 degrees. So you're always going to take the positive version of that beta angle. So beta is just equal to 70 degrees. So in the next question, we're being asked to draw 390 degrees, but that's bigger than 360 degrees. Well, let's see what that would actually look like. So we start at 0. This is a positive angle. We're going to go counterclockwise. So we're going up, and when we hit this x-axis again, that's 360. So we're just going to go 30 degrees above 360. So our 390 degree angle is just around here. So it looks like this. So it goes all the way around past 360 and up to 390. So this is 390 degrees. This is our angle, and we're looking for our beta angle. So we're looking for a related acute angle. This is where the terminal arm is. This is our closest part of the x-axis. So we're looking for this angle right here. I'll label it in green. This would be our beta angle. So to find the beta angle, our related acute angle, we're just finding the difference between 390 degrees and 360 degrees. So you can do 390 minus 360 degrees, and that's just 30 degrees. So beta is equal to 30 degrees. And here's our last question. We need to draw negative 330 degrees. So let's label this. We're at 0 over here, negative 90 degrees down here, negative 180 degrees on the other side of the x-axis, negative 270 degrees up here, and at 0 we're back at negative 360 degrees. So negative 330 degrees, that's in between negative 270 degrees and negative 360. So our angle is somewhere over here. So this is negative 330 degrees. And we need to find the related acute angle. So our terminal arm is here. The closest x-axis is the positive side of the x-axis. So we're looking for this angle right here in green. And you just need to find out how many degrees is in between here, in between our terminal arm and our closest x-axis. So you could do 360 degrees minus 330 degrees. And you actually get 30 degrees as our beta angle. But if this makes more sense to you, you can do negative 360 degrees minus a negative 330 degrees, because we're working with negative angles. You're going to get negative 30 degrees. But our beta angle is not equal to negative 30 degrees. Our related acute angle is always a positive angle. So you would just take the positive angle or the positive version of that. So our beta is just 30 degrees.